Dear student, in this video, I'll discuss cloud computing and NPTEL cloud computing course assignment 0. So we have 10 assignments. The first question is one of the header field in the IP datagram is time to live field. We all know that time to live field is what? Is the upper bound on the time that the IP datagram can exist in the network. Okay, we know this. So now we have to select which of the following explains the need for this field. So here the first is used to prioritize packet. No, this field is not going to prioritize your packet. It can be reduced to used to reduce delays. No, it can be used to optimize throughput. No, it can be used to prevent packet looping. Yes, because it is the upper bound on your IP datagram can exist in the network. Okay. So next question is threads of a process here. So here options are global variable but not heap. Second is heap but not global variable. Third is neither global variable nor heap. And fourth is both heap and global variable. Of course, it is both heap and global variable. Why it is so? Because threads within a process share the same memory map and hence share the global data like your variable, static variable, global variable, and memory that is dynamically allocated that you have allocated using malloc or killoc. So the correct option is heap and global variable. So here the next question is consider the following statement about process state transition for a system using primitive scheduling. And we have following informations like a running process can move to ready state. Yes, a running process, you have to say this. A running process can move to a ready state after timeout. Okay. Next is a ready process can move to ready state. Yes, a ready process can move to a ready state. Next is a blocked process can move to ready state. No, a blocked process cannot move to running state. Is and fourth is a block process can move to ready state. Yes, a block process can move to ready state, but not to a running state. Okay. So here the correct options are 1, 2, and 4. So option 4 is correct. Next, frames of 1000 bits are sent over a 10 to the power 6 bps duplex link between two hosts. The propagation time is 25 milliseconds. Frames are to be transmitted into the link to maximally pack them in transit. Now, what is the minimum time, number of bits that will be required to represent the sequence numbers distinctly? Assume that no time gap needs to be given between transmission of two frames. So first we see that what is the transmission delay. So transmission delay for one frame. First we have to understand transmission delay for one frame. One frame. So it is, you can see here, total number of bits, frames of 1000 bits by 10 to the power 6. So it is 1 by 10 to the power 3, or you can say 1 millisecond. And here propagation time is 25 milliseconds. So the sender can at most transfer 25 frames before the first frame reaches the destination. Okay. So here we have 25 different frames because the transmission delay is 1 millisecond and propagation time is 25. So you need 25 different frames. And if you represent this, you need, say, for 25, you need 5 bits. No? 1, 2, 4, 8, and 16. So you need 20, this 5 bits. So correct option is D. So next question is, which of the following system call result in the sending of sync packet, SYN packet. So here we have different system calls like socket, connect, listen, bind. So we know socket is used to create a socket. Bind is typically used on server side to associate a socket with a address structure. Okay, and listen is used on the server side that calls a bound TCP socket, and this connect is used on the client side. Okay, so this connect is used on the client side. Now I'm showing you, just see. So the correct option is connect because it assigns a free local port to a socket. So this is the correct option. Next question. If a class B network on the internet has a subnet mask of 255.255.248.0, what is the maximum number of hosts per subnet? So the number of hosts can be calculated. This is what? 8 ones, 8 ones, and here in 248 you have 1, 2, 4, 8. Just calculate 248, 16, then 32, 64, and this 128. So when you add this 128 plus 64, 192 plus 32, 224 plus 16, 240 plus 8, so it is 248. So total number of bits is bits are 5 bits. Okay. So here we have 5 bits for subnet. So now we have 3 bits for host field. Okay. So this 3 plus this 8. So total number of bits are 11. The total number of bits are 11. And 2 to the power 11 is 2048. But if you subtract two address, one is the network ID and second is the host ID, then total number of valid hosts are 2046. So correct option is C, 2046. Okay. So this is coming to the next question. The next question is, consider a system with three processes that share four instances of same resource type. Each process can request a maximum of 8 resources. So resources instance can be requested and released only one at a time. So the largest value of k will always avoid deadlock is what? So now first we have to write the deadlock free condition. So here the number of processes are 3. So number of processes are 3 and we have 4 instances. So resources are 4, number of resources. And for the condition for deadlock, or you can say the deadlock free condition is R should be, the resource should be greater than equal to P n minus 1 plus this 1. So R is total number of resources, P is number of processes, N is maximum need for each resource. So now put this. So here this is 4 greater than equal to this P value 3 and n minus 1 plus 1. So if you solve this, n is what? So just 4 minus 1, 3, then 3 and 3 cancel. So it is 1 greater than equal to n minus 1. Okay, 1 greater than equal to n minus 1, or you can say n is less than equal to 2. So the correct option is 2. So correct answer is D. So the next question is a direct mapped cache memory of 1 MB has a block size of 256 bytes. The cache has an access time 3 nanosecond and a hit rate of 94%. During a miss, it takes 20 nanoseconds to bring the first word of a block from main memory. Okay, while each subsequent word takes 5 nanoseconds. So the word size is suppose 64 bits. The average memory access time we have to calculate. Okay, no problem. So for this, first we have to understand the word size. So word size is what? Word size is 64 bits. In terms of byte, it is 8 bytes. Okay, so word size is 8 bytes. And block size is what? Block size is, so block size is now, you can see this is 256 bytes. 256 bytes. So therefore number of word per block is number of words per block is equal to 256 by 8. Okay, so this is the number of words per block. So now calculate this. This is 32. Okay, so total number of 32 blocks. Number of words per block. So this much of words per block. Now next is we have to calculate the average access time, memory access time. So the formula is, suppose T is the average access time, then it is 0.94 because 94% hit rate we have into 3 because the cache has access time of 3 nanosecond, and this is plus the rest, that is your 6%. So it is 1 minus 0.94 rest into what? Into 3 plus that 20, means total 20 nanosecond access time in case of miss. So 20 plus total we have 32 words, in which we are taking 31 because one access time is 20. Okay, so one word access time is 20 nanosecond and rest access time is only 5 nanosecond. So it is 31 into 5. So if you calculate this, it is approx 13.5. So the total is, you can see it is option A is correct. Okay. This is the next question is the RAM chip has the capacity of 1024 watts of 8 bits each. Means 1K into 8. The number of 2 cross 4 decoders, means we have to realize using 2 cross 4 decoder. With enable line needed to construct this much of RAM from this much of RAM is. So just divide this by this. You'll get 16 into 2. 16 vertically and 2 horizontally. So for this you need 4 cross 16 decoder. In order to realize using this 2 cross 4 decoder, you need 4 decoders, 2 cross 4 decoder in inner level and 1 in outer level. Okay, so we need total 5 decoders. So coming to the next question is the following C program is executed on a Linux system. Here we have a program and we have called this fork function how many times. So you can see here it is called at 0, then 2, then 4, then 6, and then 8 because it is less than 10. So we have called it 5 times. So total number of child process created is 2 to the power fork. So it is 5 minus 1. So total number of child process is 31. So correct option is 31. Okay.